Hey everyone, welcome back to the channel. In today's video, we're going to be going over the chain rule, when to use the chain rule, how to use the chain rule, and it's a really important step to be able to master because it's going to be used in a lot more complicated functions as well as something called composite functions. That's a function within a function. This video builds on a previous video I made going over the power rule, product rule, and quotient rule. So if you haven't watched that video, please refer to that video before moving on and watching this video. By the end of this video, you'll understand how to use the chain rule and when to use the chain rule. We'll also use this chain rule in conjunction with the product rule and quotient rule in a number of example problems. If you guys get some value out of this video, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. Alright, let's get started. So I briefly mentioned that the chain rule is used to evaluate more complicated functions or functions that are within a function, and those are known as composite functions. So if we look at composite functions to kind of review or to recall what these actually mean, what we're saying is it's a function within another function. So let's take, we have f of x is equal to x squared plus 5, so a simple quadratic there. Then we have g of x is equal to 3x minus 2, so a linear function. That's that one right there. Now h of x is going to be a composite of both of those. So it's going to be f of g of x. And it could be written like this, which is usually the method I prefer. And it can also be written like this. This one I just kind of have to think about a bit more. So whatever you're comfortable with is more than fine. So to evaluate this, what we're going to do is we're trying to evaluate f of g of 4. So what we're going to do is we're going to take g of 4. We're going to take the linear function, the blue one here, and we're going to evaluate g of 4. So in this case, it's going to be not 3 times x, it's going to be 3 times 4 minus 2. We get g of 4 to equal, that's going to be 12 minus 2 is 10. So now we have a value that we've obtained from g of x. We're now going to place this value back into the f of x function. So now we've kind of dealt with the g function, but now we're going to put in f of 10. So now we'll have, as the red function, it'll be f of 10, and this will be, instead of x squared plus 5, it'll be 10 squared plus 5. So f of 10 will equal 105. And that would be this function evaluated. So that would be the value of 4 evaluated on g of x, and then whatever we got from it, in this case was 10, and we evaluated f of x using that value of 10. So now that we reviewed what a composite function is, now we can introduce the chain rule. And the chain rule is based on composite functions. So like our previous example, we have a function h of x is equal to f of g of x, right? So it's an f of x function, and then a g of x function within an f of x function. So the derivative of that, the slope of h of x at any point is going to be h prime x is equal to f prime g of x. So we're taking the derivative of the f function, we're leaving g of x alone, we're not touching it, and then we're multiplying it by g prime of x, or the derivative of g of x. And that is the formula, similar to like the product rule and quotient rule, that we use to evaluate composite function derivatives. So the best way to go over this chain rule is to just go through a bunch of example problems. So here we have to remember the power rule, product rule, and quotient rule. And again, I've gone over a video explaining all those, so if you haven't watched that, make sure you watch that before we dive into these problems. So here we have a function f of x is equal to 2 multiplied by 4x to the power of 4 plus x squared all to the power of 2. So what I want to get you to understand is that this 2 doesn't really matter what's in here. This is a function. We can just kind of ignore this for a quick moment. And then if we were to take the derivative of this, because we know that there's kind of an x term in here, we are going to need to use the power rule. So the power rule states that we're going to take this 2, bring it in front of the expression, and we're going to minus this by 1. So to make this a bit cleaner, I'll clean this up and say that here, we're going to take that 2, and we're going to write, well, this will turn into, based on the chain rule, f prime of x is going to be 2 multiplied by 2, so that's bringing this 2 in front, and then it's going to be this whole term, so this whole term is like the g of x, so this will be 4x to the power of 4 plus x squared, so we're not changing that, right? We first did the derivative of the f of x function. In this case, that is this 2 function, that squared function being applied. And then we're going to do multiplied by g prime x. So g prime x will be, well, it's going to be 16x cubed plus 2x. This would be the derivative of this chain or this function that's a composite function. We had to use the chain rule as well as the power rule to evaluate this. I could also simplify this, and expand out these brackets if I wanted to. I'm just going to leave it as 4x, or 4 multiplied by 4x to the power 4 plus x squared multiplied by 16x cubed plus 2x. You could expand this and simplify if that was required, but in this case, just because we're going over derivatives, I don't want to make the video too long. So let's look at problem B. Here, again, we have another chain rule situation. So if we look at, I guess this outside negative 4, that is a function that's applying to all this. So that would be our f of x, and then our g of x would be everything within. So the chain rule is also known as like the outside in rule. So we always work from the outside and then go inwards. So we take the derivative of the outside function, leave the inside function alone, multiply it by the derivative of the inside function. So what we can do is we can say that g prime of x is going to be, again, we're using the power rule on this orange f of x function. So this is going to be negative 4 out in front. And then we're just going to multiply it by g of x. So we're not going to change anything just yet. Minus 5x squared plus 2. And then since I'm doing the power rule, I have to reduce this exponent by 1. So this is going to be to the power of negative 5. I'll do that in orange to make it clear that that is the f of x function. And now we do g prime of x. So we're going to do, well, it's going to be 16x cubed minus 10x, and that 2 is a constant, so that's just going to be 0. So this here would now be the derivative of this composite function, g of x. So just to kind of reiterate what the chain rule is, again, we're having an h of x function that's a composite function, so f of g of x. So the formal definition is this one right here. We do f prime g of x multiplied by g prime of x. But if we want to think about it as the outside-inside rule, we could say that the h prime x, so the derivative of a composite function, is going to be the derivative of the outside function, so outside, and then multiplied by the inside function, multiplied by the derivative of the inside function. So note where the derivatives lie here. So there's going to be one part of this that's really easy where we do the inside function, and we're not actually changing anything. And so we're going to do the derivative of the outside function, then we're going to work inwards, just place the inward function, the inside function, and then multiply it by the derivative of that inside function. All right, so now we're moving on to problem number C. And what we have here is we have a fifth root of an expression, and then one of the terms in that expression is a cube root. So the main thing that I always do for evaluating a derivative is I just always take the square roots or take the roots and put them into an exponential form. So in this case, this is going to be x plus, and this will be, I'll do it one step at a time. So this will be the cube root still, but now this is 1 over 5. And that's the first step. So then I'm going to rewrite the next one. Instead of this cube root, I'm going to write it as x to the power of 1 over 3. And again, all of that is to the power of 1 over 5. So now this is where we can actually use the chain rule, and I think it's kind of hard to see that when it's in a square root form. So the first step here is we're going to look at this part of the function. So this is kind of like f of x. So we're going to first do y prime, and it's going to be the derivative of that f of x. So this is going to be 1 over 5, or I'll do it in orange to be consistent. And then it's going to be multiplied by the inside function. So we're not changing anything here. So this is going to be x 1 over 3. And then now, I think this is important to take a pause or take a beat and say, well, it's 1 over 5. Doing the power rule, we have to subtract 1 from that. So that's going to be 1. But when we're subtracting fractions, we got to be careful, and we have to make sure that there's a common denominator. So now this is going to turn into negative 4 over 5. So now I can write up here negative 4 over 5. Now we're going to multiply or take the derivative of the inside function. So here we just have two terms, so the derivative of x will just be 1 plus, well, the derivative of x to the power of 1/3 is x, is 1/3 x to the negative 2 over 3. And this would be the derivative of this function. And now I can write it a bit more cleanly by writing it as a formal fraction. So this is going to be 1 plus 1 over 3 x to the negative 2 over 3. This is what's on top. And then note I'm going to put divided by 5, so that's this 5 here. It's going to be x plus x to the 1 over 3. And now I'm going to drop the negative and just do to the power of 4 over 5. Just like if we did 1 over x, this is equivalent to x to the negative 1. Whenever I'm switching the exponent or switching the term into the denominator, I'm going to multiply by the negative exponent or raise it to the negative exponent. So that's what I did here, and this would be the derivative of this function. So now we're going to take the derivative of a function with a couple terms. So here we have this term here, and this will just be a simple power rule. But then the term over here, this will be the chain rule, because there's a cube root applied to it, so we have to take note of that. So here it's going to be y prime is equal to, well, based on the power rule, this will be 25x to the power of 4. Now it's going to be subtracted by, and you know, what I should have done is I'm going to rewrite this as just y is equal to 5x to the power of 5 minus, and then I'm going to do the exact same thing I did in the last example. So I'm going to instead write this cube root as 1 over 3. And then now I can really evaluate the derivative more easily. So here, based on the power rule, this will be 25x to the power of 4 minus, and then we're going to do the chain rule. So we're going to keep this inside function the exact same and subtract 1 from it, so now it's going to be negative 2 over 3, multiplied now by the derivative of the inside. So this will be 10x to the power of 4 minus 21x to the power of 6. And again, if you want to write this a bit more cleanly, this will be 25x to the power of 4, and then it's going to be subtracted by, subtract 10x to the power of 4 minus 21x to the power of 6, divided by 3, 5 plus 2x to the 5 minus 3x to the 7, all of that to 2 over 3. And that is the chain rule and the derivative of this expression here. Okay, so for this example, we're now going to use the chain rule and the quotient rule. So again, if you don't know the quotient rule, I have a video going over it, but I'm going to assume you know it from now. So what we have here is we have this function, and we're definitely going to be applying the chain rule because we have to the power of 3, so that's one of the functions. So why don't we do that? We're going to do g prime of x is going to equal, well, it's going to be 3 multiplied by the entire function in here. So it's going to be 5x. Now this is going to be x squared plus 5x. And now this is raised to the power of 2, not to the power of 3. So that's the first part of the chain rule. We've done the derivative of the outside function. And we've multiplied it by the inside function. We haven't touched it. So what we're going to do now is take the derivative of this inside function here. So we have to note that this is a quotient rule. So this is like a kind of next step that we have to do. So I'm going to say that the top part here in green, I'm going to say this is f. And then the bottom part, this is g. So the quotient rule is f prime g minus g prime f over g squared. So that is the derivative that we need to do. So we're going to multiply this entire term by f prime g. So f prime is going to be 2x minus 5. G is x squared plus 5x. I'm definitely going to run out of room, so I'm going to move this over. So now that I have a bit more space, this is going to be minus, and it's going to be g prime f. So g prime will be 2x plus 5, and then multiplied by f, this is x squared minus 5x. Now this is all over x squared plus 5x squared. So that is the derivative of this function. And again, I could simplify this a bit more to make it a bit easier, but you know, this is more of a calculus tutorial as opposed to an algebra tutorial, and I don't want to make the video too long. Thanks for taking the time to watch this video. I hope you guys got some value out of it. If you did, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. If you have any suggestions on what you want me to do, let me know down in the comments below. Thanks again, and I'll see you guys in the next video.